Okay, so we will be starting right now. Thank you all for joining. Today's session is on sorting, uh, and we will be discussing a few non-trivial sorting methods. Mostly, we will focus on linear time sorting. Um, and before starting the session, just letting you all know that we will use Zoom chat to communicate. If anybody has any doubt, please ask on chat. Please keep on mute so that there are no disturbances. And feel free to ask any doubts on chat. I will be constantly seeing the chat. Uh, okay, so let's get started. So the first topic that we will start is will be on linear time algorithm. So today the entire session will be based on that, and I will start from the very basics, hoping like starting from very scratch. So before starting, like if you guys can let me know, you guys can let me know in the middle actually if I'm going too fast or you want me to go a little more slow. Okay, so let's start with a simple problem. Let's say you have a jar, okay, and that jar has two types uh, of candies. One is red and the other one is black. So there are a lot of candies in this jar. Red and black candies are there. Now, a very simple problem that let's say I ask you to sort the candies in the jar between red and black. Okay, so there are only two types of candies, red and black. And the question is that you need to sort all the candies in this jar in red pile and black pile. Basically, you want to segregate. So this is very trivial problem, which like you generally see any kid can solve it. You will just pick any candy and you'll ask two questions, right? You'll basically ask only one question. Is it black, let's say? If the answer is yes, then you add it in the black pile. And if the answer is no, then you simply add it in the red pile. If you keep just a minute, please be on mute. Uh, Everybody, please be on mute.
Yeah, sir.
Yeah, please be on mute so that nobody else is disturbed. Okay. So if you have any doubts, please ask on chat. I am seeing chat. Okay. So cool. So very simple, right? If there are two types of candies in a jar, you pick any one candy, you ask the question, is it black? If it is black, then you add it in the black pile. If it is not, then you add it in the red pile, right? And after doing this process, for as many number of candies are there, you will get two piles. One will contain all the black candies and one will contain all the red candies, right? This is a very simple problem. What do you think is time complexity? What would be the time complexity to solve this problem? And for those who are not aware of time complexity, in a very naive term, what will be the time to sort the candies into black and red pile uh, on the basis of the number of candies? So if there are n candies, the time to sort the candies into to the two piles will be proportional to what entity? Order n square, n log n. Anyone? You can write on chat. As you can like in the time you figure out, I'll explain. Like every candy you pick, you ask one question, and on the basis of one question, you decide which pile it goes. So one question per candy. There are n candies, so times n. So it's proportional to the number of candies. So as many number of candies are there, that much time you will take to sort this. So in order of n time, awesome. So in order of n time, you will be able to sort this jar. Okay. This is also type of sorting, right? So this is sorting of an array that contains only two types of numbers, right? And you can do it in order of n. A very intuitive way to solve it. Now, let's look at a similar problem. Let's say you have an array of zeros and ones. So the only two numbers which will be in the array is 0 and 1. So this array has only two types of numbers, 0 and 1, and they are mixed. So what will be the time complexity to sort this array? Is it very similar to the jar question, which had black and red candies, right? What you will do is you will pick any number and you will ask, is it 0? Because you know that the numbers are in range, can only be two things, 0 or 1. So if the answer is yes, then it goes in the 0 pile. If no, then it goes in the 1 pile. And at the end, you know, you get all the zeros here and you get all the ones here. And then you just need to concatenate the result and you will have the array, which is 1, 2, 3, 4, 5 zeros will come here. And 1, 2, 3, 4, 5, 6 ones will come here. And you will just concatenate them. And that's your answer, right? And the time complexity to solve this is also order of n, n being the total number of elements in the array. Okay. So far clear? If there is any doubt, please ask on the chat. Happy to answer. So we saw how the jar problem got converted into a binary number sorting, right? So this is a binary number sorting, and both can be done in order of n time. And it is very highly intuitive and very trivial way. So far we are seeing we can sort these type of problems in order of n. Now let's make it a little bit more complex. Okay. So let's say you have the same array, but now your the numbers can be in range 0, 1, and 2. So now I'm increasing my range, and you have these numbers. So now what will be our algorithm? Now, how can we sort this array? And what will be the time complexity to sort this array? Let's repeat the same step that we did before. We pick a number and we ask a question. Can the question be the same old question? Is it 0? If it is yes, then I'm happy. I get the 0 pile. What happens if it is no? I have two options, right? So here you will be asking two questions. Is it 0? If the answer is yes, fine. And then if it is no, you again ask, is it 1? If it is no, you ask this question. And again, on the basis of answer of yes or no, you again get the 1 pile and 2 pile. So now for each element that you are picking, worst case, you are asking how many questions? 2 questions. How many elements are there? N elements are there. So what is the time complexity? Proportional to order of n again. So we are seeing that these type of problems, even if we start increasing the n, we are seeing a linear time complexity. Let's make it more general. Let's make it a little bit more advanced, and let's see what's the time complexity now. So now we have an array. Right? This is the array. It has some numbers, and the range of numbers belong 0, 1, 2, k minus 1. Okay, so basically there are k types, and can anybody tell me now what will be, how will you solve this problem and what will be the time complexity? Doing the same step. So now again, you pick any number here, and how many questions now you will need to ask. So think intuitively. Here you had 3 types of numbers. You had to ask 2 questions. Earlier you had 2 types of number. You had to only ask 1 question. Now there are k types of numbers. How many questions will you have to ask? Right? You'll firstly ask, is it 0? If not, is it 1? If not, is it 2? So on and so forth until k minus 1 just before this, after which you know it is which type. So you ask k minus 1 questions, worst case, and then there are n such numbers. So in order of n times k minus 1, you will be able to divide this whole array into piles of 0. You will have a pile of 0. You will have a pile of 1. You will have a pile of 2. So on, you will have a pile of k minus 1. And at the end of this, you will just concatenate them and you will have a sorted array, right? And the time complexity, like we are seeing right now with the algorithm that we are using, is order of n times k minus 1. Let's see. Okay. But k is a constant, we can ignore. Yes, you can ignore. K is a constant, but here it's a variable, right? 0 to k minus 1. It's not really a constant right now. So n times k minus 1. Okay. K being k is the range of the type of numbers. Let's see if we can improve this. And before we go, let's name this algorithms because we will be studying multiple such algorithms. So this type of algorithm belongs in bucket sort. Why bucket sort? So the piles that you are creating of different types are called buckets. And once you bucketize all the numbers, you can they are just sorted because your buckets are sorted, and that's what is bucket sort, right? So just go back and see. Here you created k minus 1 buckets. The buckets indices were always sorted, right? Because they were nothing but the range of the numbers. And once you divided them into the buckets, you can just concatenate the buckets and you will get the sorted answer with you. Hence, this is called bucket sort. And now the time complexity to solve a problem using bucket sort depends on what implementation you are using. They are generally linear in nature. Okay, like we saw in so many examples, they all were linear with respect to the number of inputs. Okay, so now that we have read about a few problems, like we firstly did black and red candies, and then we did zeros and ones, binary bit sorting, and then we did 0, 1, 2. Now we have solved it for k numbers, right? From if there are k types of integers, how will you solve? Now let's try to know the algorithm, what the algorithm says. And before that, I will introduce you to a concept. So right now, our buckets were defined by a number, right? 0 is a bucket, 1 is a bucket, 2 is a bucket. Bucket sort is more general. For example, let's say you have array, same question, but now your numbers range from, let's say, 0 to 10 power 3,000. Okay, so there are 1,000 types, and let's say number of elements are also, let's say, almost 1,000. Okay, 10 power 3. So now clearly, if you use the traditional method that we were using, right? If you keep asking k minus 1 questions, here k is huge. 10 power 3 minus 1, you result in 10 power 3 times 10 power 3, which is n square algorithm, which is not really good. So far we were doing linear. But since the range of the numbers can be proportional or equivalent to the number of elements in the array, this becomes a order of n square solution. So in bucket sort, we have concept of range buckets. So till now we were doing single element buckets, like bucket I is all zeros, bucket I is all ones, all twos, all k minus ones. Now we can also do in range, like bucket I is all 0 to 10 in one bucket, all 0 to 9, right? All 0 to 9 in one bucket. And then you can say all 10 to 19 in another, 20 to 29 in another, 30 to 39 in another, so on and so forth. And since there are 1000, so the last bucket will be 1000 minus 1, right? The range is 0 to 10 power 3 minus 1, which is 999. So 992, 999. How many buckets are there? Very simple. We have one bucket has 10 elements and there are 10 power 3. So there are 100 such buckets. So you are seeing that you reduced your bucket size by order of 10. Now you have only 100 buckets. And now your questions are also in range. Like, is the number you have picked is in this range, 0 to 9? Is the number that you have picked is in 10 to 19, 20 to 29, 30 to 39, so on. And you just create a bucket of these. And then a new steps comes in. So till now, because we had earlier to this, we had single element buckets. So we had all zeros in one bucket, all ones, all twos, all threes, and because 0, 1, 2, 3 are inherently sorted, so we could just concatenate the buckets. But now when we list all elements from 0 to 9, let's say you get something like this: 0, 1, 0, 2, 9. This is not sorted, but they are bucketized, right? All numbers from 0 to 9 are here. So now a new step comes which sort these buckets individually. So now you individually sort these buckets, create a sorted bucket. And after this, you will just concatenate these buckets and you will have your answer. So this is bucket sort. Okay, this is more general. Your buckets need not be of range 1. They can range, they can be a range in itself. So, and then you divide the problem. So basically bucket sort says if you have an array of n elements, and the range of elements in the array is from 0 to k minus 1, then the step 1 is create range buckets. Range bucket means decide how many buckets you will have. So like in this case, we had 1000 range. So we created 100 buckets of range 10, right? 0 to 1, 0 to 9, 10 to 19, 20 to 29. So you need to take a decision on what is your bucket size and what are the total number of buckets, right? So simply put, you create buckets. And inside creating bucket, you need to take two decisions. One is bucket size and another is total buckets. Okay, so you decide on your bucket size, your total buckets get fixed. You decide total buckets, your bucket size gets fixed. Okay, so you just need to pick any one of these. You pick the bucket size. Like we picked 10 bucket size in the previous problem, there were 1000 range, so 100 buckets. And if I choose 100 buckets, then my size is obviously 10. So you just need to pick either one of these. Once you create your buckets, now you need to pick a number, pick every number and decide which bucket, right? So far, we were doing it in a brute force fashion. We were asking questions. Is it 0? Is it 1? Is it 2? Is it 3? Is it 4? But let's say this is your bucket range, 0 to 9, 10 to 19, and I give you a number 89. Can you tell, will you ask all these questions? Is it 0 to 9, 10 to 19, 20 to 29? If you know your bucket size and bucket range, you can immediately figure out which bucket it will go without asking so many questions. You know that it will fit in the 80 to 89 bucket, and that's the ninth bucket from top, right? All you need to do is use basic maths. You divide it by your bucket size, which is 10, and that's your and that will give you your index, right? So this is the 0, 1, 2, 3, 4, 5. This is the eighth bucket. Yeah, right. In a computer language where counting starts from 0, this is the eighth bucket. So you get your bucket number, and you simply append 89 in this bucket, right? You just dump this number 89 in this bucket, right? So figuring out which bucket a number is not really a order k minus 1 question. Depends how you are creating your buckets. If you are smart enough to create buckets which follow a pattern like we have done, you can decide which bucket it lies in order of 1 using basic mathematical expressions, right? And if your buckets are homogeneous, as in they are of equal range, like all the buckets are of size 10, and there are k buckets, you can come up with a formula, and formula is simple. If you get any element from the array, just divide it by the bucket size, and you will have your bucket index, in which bucket this will go. So you pick every number and dump in the correct buckets. What's the step 3? Step 3 is sort each bucket, right? And you can use any sorting. You can use bubble sort or any type of O(n) square sorting here to sort the bucket. And once you sort the bucket, you can concatenate results, right? You can simply concatenate results. Okay, before moving ahead from here, open to any questions that people have. Any questions on bucket sort? Any questions that you have on this algorithm? So the algorithm says that you need to have an array and you need to know what is the range of elements in that array. If you know the range and the number of elements in the array, you firstly create buckets. To create the bucket, you need to fix either bucket size or total number of bucket. Let's say you want to create buckets of size 10. There are 1000 elements in the array and range is 100, 0 to 100. So you will create 10 buckets, each bucket of size 10. After that, you will pick every number from the array and decide which bucket it lies in. For each number, you take order of 1 time to decide which bucket it goes. So if I have bucket of size 10 and the range is 100, so I know that I have 10 buckets, each of size 10, and a number 77 comes, then I know that this number will go in the 7th index bucket, right? The first index will be 0 to 9, then 10 to 19, then 11 to 19, then 21 to 29, 31 to then 30 to 39, then 40 to 49, and so on and so forth. 70 to 79 will be the 7th bucket in computer language because the counting starts from 0. Normal counting, it will be the 8th bucket because it is 0 index. So just divide 77 by bucket size, you get the index. Once you get the index, just dump this number in that bucket. Buckets are nothing but you can think of like individual arrays. You keep at individual lists, you keep appending to that list. Your list is not guaranteed to be sorted because your buckets are a range, right? So in one bucket, let's say 0 to 9, you will have all numbers of range 0 to 9, not necessarily in sorted order. So you sort each bucket using any sorting algorithm that you know, even O(n) square is fine. You sort each of the buckets And once you do that, you just concatenate the results and you have a sorted answer for the entire problem. Okay, so this is the bucket sort, and criteria to use this is you should know how many elements are there, what is the range of the numbers, and this is also a very necessary criteria that the numbers should be equally distributed, uniformly distributed. Imagine that you have 100 elements of range 0 to 100, but all the elements are 100. Like all the elements are in one bucket. Let's say all the elements lie in this range 0 to 9. So all of them will go in your 0 to 9 bucket, and then you will sort them in O(n) square, and your time complexity becomes O(n) square, which is not that great for bucket sort to work. Although it works, but to get bucket sort can be used in only those cases and can be preferred over n log n algorithms if you know the number of elements, you know the range, and the numbers are uniformly distributed, meaning with respect to the buckets that you are creating. So your bucket should be uniform in size. It should not be that one bucket has all the elements in that array. Then sorting that is what you are looking for, and you will sort in O(n) square. And so worst case, bucket sort is order of n square, and best case, we will figure out the time complexity. But before that, I will be open to any questions that anybody has. Any questions, guys, right now? Are you guys able to follow? Can you write yes, no, fast, slow? Okay. Yes. Yeah, I'll come to how you want to choose. So choosing bucket size is not part of the bucket sort algorithm. You can choose any bucket size. Once we come up with the time complexity, you can make that choice. We will come to that. But till now, are you guys following? I haven't completed bucket sort yet. Okay. Any doubts you guys can ask on chat. I'll be happy to answer. So now now that we know that worst case is order n square, where all the elements fall in one bucket and you just sort that bucket and get the answer. And that's order n square. What's the average case, right? What if the elements are uniformly distributed, which are in general? And what will be the time complexity then? So let's estimate time complexity of each step. Creating buckets, creating buckets is basically just choosing the bucket size or total bucket. So that is not going to take any time. Once you come up with a strategy of choosing a bucket size or total buckets, you can choose that before starting your algorithm. For each element, you will take order of one time using a basic mathematical expression to decide which bucket it goes. But there are n numbers, so here you take order of n time, right? If you have a good mathematical expression to know in which bucket it goes, and in 99.999% of the time, you will be creating range buckets, right? You will be always creating range buckets, which are very mathematical in nature. Like every bucket will have a constant size. And if you choose your bucket size, you know total number of buckets, and that's it. So you can use a simple mathematical formula to know which bucket that number will go. In order of one time, there are n elements in the array. So order of n overall, the second step takes. Sorting each element, sorting each bucket. How many elements will be there in each bucket if the numbers are uniformly distributed? Let's say there are k buckets, okay, or b buckets. Let's say there are b buckets with whatever strategy you came with. There are n numbers. So, and they are uniformly distributed across buckets. So each bucket will have how many numbers? In best case, we are thinking of average case, right? In average case, it will be uniformly distributed. Let's say that's given. So each bucket will have how many numbers? Is that clear? Like any doubts in this? And if let's say if you use order of n square sorting, then n by b whole square. And since there are b buckets, so this is the time which it takes to sort each bucket. And concatenating results are again order of n. Like you go through all the buckets and just concatenate. It is order of n. If you implement, you will know. So what's the time complexity? This takes no time. Order 1, then order n square by b square times b, and then n. So we can say that the time complexity is n by n square upon b. B being the total number of buckets. So answering questions which came in chat. So for bucket sort to be linear, total number of buckets should be order of n, which is obvious. Why it is obvious? Think of the problems that we did before. Like, or just this simple mathematical expression. Like if you have one bucket for each number, then that's the best, right? So that gives you order of n. And you will always do better than an n log n algorithm if n, you can come up with a formula. So basically, I will not go complicated much, but you should remember that time complexity of bucket sort is this. And if you keep this order of n, number of buckets, if you keep it order of n, then you get linear time results. Okay. And if you want to do better than n log n, then what do you need to do? You can write it like this. So if you need it to be better than n log n, then log n needs to be greater than n by b. And you can just solve this. So if your total number of buckets are n by log n, then also you are doing much, much better. So keeping it very simple. So depending on your bucket, your time complexity is defined for bucket sort, and this is the time complexity. Time complexity is of order of n plus n square by b. It is linear time if the number of buckets are proportional to the number of elements, which is in most cases, and that's it. And worst case is, remember, order of n square. If all the elements get bucketized into one bucket, which means they don't follow uniform distribution, where you should not use bucket sort. You should only use bucket sort if you know how many elements are there in the array, if you know the range of elements in your array, and if you know for sure that the numbers are uniformly distributed, then you can use bucket sort to solve the problem in linear time. Okay. Any questions? Any questions, guys? Any questions right now? Any doubts? Should I move ahead? Move to some problems? Okay, I'll take that as a yes. So now let's move to a very basic and a very interesting problem. And like need you guys to interact on chat for this. So the question is, sort 1 million 8-bit integers. And your options are you can use some variation of bucket sort to solve this. So can you use bucket sort to solve this? Of course, you can use any sort to solve this. What's the best algorithm to solve this? Bucket sort, merge sort, quick sort, or bubble sort? What would you use? So remember what I said, you can use bucket sort if you know how many numbers, you know the range, and if you know the numbers are uniformly distributed. You can assume the numbers are uniformly distributed because any range of any randomly generated set of numbers are always uniformly distributed. That is a mathematical certainty that if you randomly generate 100 numbers, they will be uniformly distributed without any bias towards any bucket. Very intuitive. So in this case, you have, n, 1 million. You know the range. Every number is, what is 8-bit? 8-bit is how many types can be there? 2 power 8. What is 2 power 8? 256, right? So you know that the range of your number is 256, which would probably be from -128 to 127 in this case. So you have 256 types. You have 10 power 6 numbers, and you know If nothing is given, you know that they are uniformly distributed. So average case, not best case, average case, what you will use. So if you use merge sort, in all cases, you solve it in order of n log n. If you use quick sort, worst case, order of n square, best case, average case also n log n. If you use bubble sort, then always n square. So far, best case is n log n. What if you use bucket sort? Let's use the techniques that we have studied. So what is this problem? You have a list of numbers and your range of numbers is between 0, 0 to 255, let's say, to keep it very simple. Although it will be from minus 127 to 128, but for sake of simplicity, let's say it's from 0 to 255, unsigned. Okay, let's add unsigned here, 8-bit unsigned integers. So the range is 0 to 255. And if you use your simple funda, you create 255 buckets and you bucketize them. Each element comes, you look at the number, you know which bucket index it is, you just dump them, and order of n time, you will be able to bucketize them into 255 buckets, right? Let's say you get number 128. So do you ask one like 255 questions to know which bucket it goes? No, obviously it's 128, so it goes in the 128th bucket. If it is 0, it goes in the 0th bucket. If it is 1, it goes in the 1th bucket, right? You can create an array of arrays, list of lists, and you can immediately identify your bucket index and just dump the number, right? And because the numbers are all zeros here, all ones here, all twos here, you don't need to sort the buckets. You just need to concatenate them and you'll have the answer. So the time complexity to do this will be n times nothing, order of n. So bucket sort can solve this in order of n time, right? Any questions? So what algorithm would you use to sort 1 million 8-bit integers? Bucket sort will always solve them in linear time. This is the correct answer, right? Let me give you one example where you would not use bucket sort. Let's say you have 100 8-bit integers. Let's say here also unsigned. So you have 100 numbers and they are 8-bit integers, right? So now what algorithm would you use? Firstly, is this solution clear? If you have 1 million 8-bit integers, you can solve this problem using bucket sort in order of n time, right? Because of the way we are solving it, we follow the approach. We create range buckets. Here, bucket size is 1. Total number of bucket will be 255. Pick every number, decide which bucket it goes. In order of one time, we know we see the array I and it goes in the that index, that bucket. We get the bucket. We sort each bucket. This order of this takes no time because all the buckets are always sorted, because the buckets are not range buckets, they are individual element buckets. And you just need to concatenate the result in order of n time and you get your answer, right? So in this case, you can use bucket sort. Again, in this case, you can use bucket sort to solve the problem, right? So is it clear? So whenever you have, the number of elements that you want to sort, and the range of the elements you want to sort, and that they are uniformly distributed, which is by default. If it is not given, then in average case, your time complexity of bucket sort will always be order of n, because the numbers are generally uniformly distributed, right? Just like quick sort, we say average complexity is n log n and worst case is order of n square. Here same, worst case will be order of n square and average time complexity will be order of n. So this wraps up bucket sort. Any questions so far? Any questions on bucket sort? Now, let me give one example, which I wanted to give the last time. One example where you will not use. So let's say the same question. You want to sort 1 million integers. Sort 1 million integers. Which sort will you use? Option includes bucket sort, merge sort, quick sort, and bubble sort. So you are sorting 1 million integers, but remember there is no range. You don't know the range. Last time we knew the range because they were 8-bit. We know 8-bit range is only 255, 256. Here you don't know any range. In these general questions, you will always prefer any n log n sorting algorithm. Our correct answer here will be merge sort, right? Merge sort and not quick sort because worst case merge sort is also n log n. So you'll use merge sort over bucket sort. You'll not use bucket sort because you don't know the range. If you don't know the range, how will you create the buckets, right? That's the problem. And because of this, you will always use merge sort. So if I tell you to sort 1 million 8-bit integers, you'll use bucket sort to solve it. Uh, I'm not saying you'll always use bucket sort. I'm saying bucket sort will solve it in linear time. There are other linear time algorithms also. So bucket sort can be one algorithm which solves it in linear time. But if I give you a very general question, 1 million integers, sort them, you will not use bucket sort because you cannot use. You don't know the range. Hence, you can't use bucket sort to solve this. So is it clear so far? Are you guys following? Any questions before? So now the next topic we will go is radix sort. Before moving ahead, like just asking if there is any doubts you can ask. I can answer them. You know the time complexity also, right? Bucket sort time complexity is n square by b plus n. In general, you will see people saying it is a linear time algorithm, which makes the assumption that the number of buckets are proportional to n, they are order of n. But you should know that merge sort time complexity is order of n by b plus n. If you have range buckets, if you don't have range buckets, if you have individual buckets, like we solved for this 1 million 8-bit numbers, your buckets need not be sorted, then it is strictly order of n, because there is no sorting inside the buckets happening, because the buckets are not range buckets, right? So remember, if you are using range bucket, this is the time complexity. Range bucket meaning you have buckets defined like 0 to 9 one bucket, 10 to 19 one bucket. Then this is the answer. If you have individual element buckets, then it is always order of n. Okay. So okay, I think any questions before I move ahead? Any doubts here? Any specific questions? Can we say less buckets and more number of elements means preference to bucket sort over? So the question is, can we say less buckets and more number of elements per bucket means preference? No. This is your formula, right? If you have range buckets, so there are two types of solutions using bucket sort. One is you create range buckets. One is you create individual buckets. Individual buckets are the problems that we solved initially, like black and red candies. Buckets were black candies and red candy. It wasn't a range. 0 and 1, sort them. One bucket is 0, one bucket is a bucket of 1. So all zeros go in one bucket. When the buckets become a range, like 0 to 9 is one bucket, 10 to 19 is one bucket. Now the elements that will come in this bucket, all the numbers from 0 to 9 will come. They won't come always in sorted order. So you need to sort the buckets. So when you have range buckets, then you need to ask this type of question, and the answer lies in this formula, n square by b plus n, which means total number of buckets. B is the total number of buckets. B is not the range of buckets. So if there are B buckets, right, then B should be large enough, optimal enough, so that this is, and B should be of range order of n for this to be linear. So less buckets does not mean that your algorithm will be better. It's opposite. If you are using range buckets, you want to have as many buckets as possible, so that when you sort individual buckets, there are very less numbers, because when you sort individual buckets, you will use some order of n square algorithm to sort that, and you want the number of elements in a bucket to be as less as possible, so that the n square trade-off is as less as possible, because that's the only time consuming step. If you see the algorithm, then sort each bucket. This is the one which is taking this time, n square by b square times b, right? Where n by b is the total number of elements in each bucket. So you want this to be as less as possible. So if you create more number of buckets, if you are using a range bucket solution, then you want to create many buckets so that your solution is optimal. If you are using individual buckets, like in case of 8-bit numbers, we created individual buckets, right? 0 is one bucket, 1 is one bucket, 2 is one bucket, 3 is one bucket, 255 is one bucket. Then you don't need to sort individual buckets, because why do you need to sort do you need to sort an array of all zeros? No, they're all zeros. I don't need to sort them. So this becomes order of one. So the most time consuming step in the algorithm is already solved if you solve the problem using individual buckets. So that's why I wrote here that if you are using range bucket, you need to pay importance and heed on how many buckets are there and what is the size of the bucket. And this is the formula which will drive you towards the correct answer. Your number of buckets should be proportional to the number of elements in the array. And if you are not using range buckets, then you don't need to even worry about it, because the answer will always be order of n. Does that answer your question, Tanya? Okay.
Okay, Aditya, I have one question. Like, since bucket sort and count sort are similar, right? In count sort, we're just counting the elements in like corresponding to the frequency, right? Then we are like filling up the main array, right? So when to use count sort and when to use bucket sort? So I'm confused in the same.
Okay. Thanks for the question. Please, we are recording this session, so please type your question on Zoom chat. Also, if you unmute yourself, there can be some background noises. So please keep on mute. You can type your questions here, and I'm reading your chat. Thanks for your question. Answer for the question is, so the question he has asked is when to use bucket sort and when to use count sort. So because we haven't studied count sort, I will not go into the detail, but to answer your question, bucket sort, when to use count sort, since I hope you know what count sort is. So you can use count sort also only when you know the range of, they work on the similar criteria. You should know the range of the numbers, only then you can use count sort. Just like if you don't know the range of numbers, you can't use bucket sort. Like in this case, 1 million integers, you can't use count sort to solve. But here, you could have used count sort to solve the problem if you know the range of the numbers. So to answer your question, you can use, whenever there is single bucket sort, you can always use count sort there. No issues there. But bucket sort is more general. Like you saw the concept of range buckets. Those are not applicable to your count sort. Count sort is a subset of bucket sort where single buckets are used. Okay, that's why they are not very separate. Although the implementation is a bit different, where you just store the count of the numbers and not the elements itself. You can counter that by saying that it's just a tweak in implementation of bucket sort where single element buckets are there. Okay, but bucket sort is a very general concept. Like you have seen, we can have range buckets, and computer theorists define this as bucket sort. And single element bucket sort is also a specialization of the generalized bucket sort. So bucket sort is the sort of paradigm of algorithm of linear time sorting, in which count sort comes, single element bucket sort comes, but the general bucket sort is the bucket sort which the theory says. Okay, hope that answers your question. And short answer, yes, you can use them interchangeably. If you are able to use a single element bucket to solve the problem using bucket sort, obviously these three conditions have to be fulfilled. You should know number of elements, you should know the range, they should be uniformly distributed. Then you can use bucket or count sort and you can solve your problem. Okay, that's the short answer. For count sort, you don't need them to be uniformly distributed as well, because anyway, because you just need to know the range and the number, and that's it. For bucket sort, because we are talking in very general sense, we want because our buckets can be arranged, we want the numbers to be uniformly distributed. Okay. Do we choose single when we know that there would be repeated elements? No, I did not say any of those. You should use bucket sort only when these three conditions. Don't overcomplicate things. You should know the range. You should know the number of elements. I do understand the intuition of your question. If there are more and more repeated elements, then you are likely to use a linear time sorting algorithm, which was this case, 1 million 8-bit numbers. There are only 255 integers, but now you have 1 million of those. So obviously most of them would be repeated, but don't complicate it. A simple rule of thumb is you should know the range, you should know the total number of elements, and if it is uniformly distributed, it's very good for bucket sort. But these two are the mandatory criteria. Without knowing the range, you can't use. I gave a counter example as well. If you don't know the range, 1 million integers, you can never use bucket sort or count sort to solve the problem. These can't be used. Okay. So moving ahead, any further questions you can type in the chat. Now moving ahead to the next class of algorithm. This is also a very, very, what do we say? Very, very important algorithm. And I'll draw 3 stars here. This is a linear time sorting algorithm. It has its own conditions when and where you can use them. But this is a sorting algorithm that you can use for numbers and strings to solve. So if you are appearing for any interview, if you're learning sorting, you should know radix sort. Your sorting is incomplete without knowing radix sort, because of that's the importance of this sorting. So now we will start radix sort. So we are on time. Okay. So let's start with again some intuition. So okay, let's start with a simple. Let me actually introduce the algorithm first, because the algorithm is very beautiful of radix sort and works like a magic. So and it is very closely related to the single bucket sort that we have solved, like single element bucket sort that we have done. So let's say you have an array. Okay, I will explain this with an example. Let's say you have an array, and you have, let's say, these numbers: 123, 111, 12, 1, 89, 99. Okay. So firstly, you write this array. I'll rewrite this array like this: 123, and you will know why. Firstly, just focus on what the algorithm is, and then we will come up to the time complexity and maybe implementation. So what I did is I found what is the maximum number of digits that any element has in this array, which is 3, and I convert all the elements into 3 digits. Okay. This is the first step, is count the number of digits. You can read it like count the number of digits of the maximum element. Step 2. Step 2 is you pick the least significant digit of each element in this array. So what is the least significant digit of each element in this array? Right? These are the least significant digit, ones place of each element. With respect to this, sort the elements. And we will use our algorithm that we have studied already, bucket sort, to solve this. So one digit can range from 0 to 9, right? So it is classic bucket sort solution. You have an array of numbers, and each number can be from 0 to 9, sort them. So what do? You create buckets of, you create 10 buckets, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you take a number, you see the number, you dump that into that index bucket, and concatenate the result, and you have the answer. So without doing that, just simply see 3 1 2 1 9 9. So and one more thing. So firstly, 1 is the first thing. So 1 1 1. Then comes 0 1 1. Then what comes? After 1 we get 2. So 0 1 2. What other elements we had in this array? 3 1 2 1 9 9. So then 3 comes. What comes later? 0 8 9. 0 9 9. Now repeat it for the next least significant digit, which is the tens place. Okay. So now use this and sort the array. So now we are again sorting this. So now what are the numbers? 1 0 1 2 8 9. So 0 is the first number, right? Now when we sort, what is the next number? After that, I think there are no zeros. So 1. So what numbers are there with 1? 1 1 1 0 1 2. That's it. So 1 1 1 0 1 2. What other numbers are there? So 1 0 1 2 8 9. So 2 will be there. 123. What are the other numbers? 0 8 9 and 0 9 9. Right? And the last step is the next significant. So you repeat it till as many digits the maximum number has. So it had 3. So this is the first step, second step, and third step. You'll have your answer. Now, what is the next least significant digit? Is the highest significant digit, which is this. And now we sort according to this. Okay. So 0. So firstly 0 0 1 comes. Then what are the other zeros? 0 1 2. 0 1 2 comes. What are the other zeros? 0 8 9. So 0 8 9 comes. Then what are the other? 0 9 9. 0 9 9 comes. Then what are the other? I think there are two ones. 1 1 1 and 1 2 3. They come and this array becomes sorted. So like I said, it works like a magic. So every time, so so this is the algorithm. The algorithm is find the maximum digits in array, repeat. So let's say this is D, repeat for D times, and each time pick, for each time, let's say pick the, we need to pick the least significant digit, then second least, third least, fourth least till D time. So let's say we iterate from 0 to D minus 1. So pick ith least significant digit and sort, and that's it. And you will have your answer. Okay. Let's take another example. And if you are following, what you can do is write answer of each step. Will be good interaction. So let's say again, these are the numbers: 123, 889, 991, 232, 141, 87. So let's say we want to sort this. So firstly, we convert this into a similar digit array, right? And now what do we do? Now, like you can start writing the answer. First step, we will sort with respect to the least, the 0th least significant digit, which is the least significant digit. So what will be the answer of first step? If you have understood, you can write it. So 3, 9, 1, 2, 1, 7. So we'll place the ones before 141, 199, 141. Then what comes? Then the twos come, 232, right? Then I see a 3, 123. So 3, 9, 1, 2, 1, 7. So I think 7 comes next. And then 889. Okay. Now in the second step, you sort with respect to the second least significant digit, or in computer indexes, the first least significant bit, because you already solved with respect to the 0th least significant bit. So now what will be your answer? Can anybody tell what's the answer now? So 9, 4, 3, 2, 8, 9. So 9, 4, 3, 2, 8, 9. So 123. 2 is the least. Then I think 3. Then I think 4. 9, 4, 3, 2, 8, 8. So I think after 4, the 8s come. 0, 8, 7, 8, 8, 9. And then the 9 comes. And now yet another time, sort with respect to the third least significant bit. And the numbers are 1, 2, 1, 0, 8, 9. So I think 0 comes first, 0, 8, 7, then 1, 1, 2, 3, then 2, 3. No. So 0, 8, 7, 1, 2, 3, again 1, 2, 1, 0, 8, 8. So there is one more 1, 1, 4, 1, which will come before. So 0, 8, 7, 1, 2, 3, 1, 4, 1. Then the 2s will come, 2, 32, and then the 8 will come, 8, 8, 9, 9, 9, 1. And this is sorted. Okay. So are you guys clear with what the algorithm is? Any questions on what the algorithm is? No, you cannot start from the most significant digit, and it will lead to a wrong answer always. Why? Because the last sorting that you do is the highest significant bit, and the last, remember, we don't sort any further after the sorting with respect to the highest significant bit. There is a reason for that, because that is the answer. So you do it in the end. You start with the least and you end with the highest and leave it at that state. If you start with the highest and you end with the least, then you sort with respect to the least significant bit and it will not be sorted, never be sorted. You need to go from the, because highest significant bit has the highest importance in the sorted order, right? Just see how 991 moved around in this example. 991 was here. After first sorting, it was here. After the second sorting, it went here and became here. If you reverted it, 991 would have come first because 991 has least significant bit, which is 1. But why is 991 the heaviest number? Because of the 900, right? Because of the highest significant bit. So that has to happen in the end so that you leave the array sorted. So if you do it inversely, you will get wrong answer. So you need to start from the least significant bit. No. You won't reverse sort, in my opinion. That will be, you'll end up with a random order.
It won't be right. Probably you have numbers like 0, 9 and 0, 1, 8. Yeah.
Yeah. That's what I said. You'll end up with a random order. Okay. Now, one more very key thing that people do an error in. This sorting is done in stages, right? Stage means this for loop, 1, 2, 3. Correct? This sorting happens in stages, and what are the stages? We sort the numbers with respect to the ith least significant bit. Okay, and we repeat it. We rely on the answer of the previous stage and we repeat it. Hence, it is very important that in case of ties, like there were two ones here, right? 123 and 141. So could I write 141 here and 123 here? No, I'll get wrong answer. The ordering is very important. In case of tie, follow the order of the occurrence. So 123 first, 141 second. We don't compare the number which is greater, which is small. We close our eyes and we pick the one which comes before. So in this case, 123 came before, so we pick it. And it will always be correct because the previous numbers would have been in the correct sorting order because we are proceeding from the least significant to the highest significant bit. So another key point. So I'll add an asterisk and say this is, we call these like you need to, we call it stable sort. Stable sort, which means you should not mess up with the order. Okay, order needs to be stable. So remember this one and you will never do an error. So now that you know radix sort, so radix sort is basically finding the algorithm. Let's come to the algorithm. Find the maximum digit in the array, which is what? You find the maximum number in the array. You find how many digits it has. Let's say that is D. Iterate from 0 to D minus 1. Pick the highest least significant digit and sort with respect to that. How will you sort with respect to that? You will use bucket sort, which we have already studied. And this bucket sort will be of nature. You have n elements and the range of the numbers are between 0 to 9. You will create 9 buckets and you will sort in order of n time. So each step is taking order of n time. There are D digits. So we solve this in how much time? N times D. So the time complexity of radix sort time complexity is order of n times D, D being the number of digits of max element. Got it? And for integers, this can be assumed as constant. Why? Right? Even a 64-bit computer can store a digit, a number which has how many digits? Maximum it can store 2 power 64. And 2 power 64 has how many digits? At max 18 digits, I guess. 18 or let's say 20 digits even. So 20 is a constant, right? So you can assume this is a constant. You can't store in your computer a 64-bit integer which has more than 20 digits. Even if tomorrow we move to 128-bit, then this just grows linearly, 40 digit, 80 digit. So this is constant. So we consider for integers, this is as a linear time algorithm. When you do this on strings, same process, you can do it on strings. Then we say time complexity is order of n times length. And length is the length of the longest string. Here it matters. So n times length, and this is the best sorting algorithm for strings. Radix sort is the best sorting algorithm to sort strings, and the time complexity is n times length of the maximum string. For numbers, it is order of n. If somebody tells you n times d, he's not wrong, he's right, but d is capped because of the world we live in, right? Number of digits can't grow exponentially. You can't have a 100-digit number. You can't store it in any laptop, any computer. It becomes impossible. Even if it is 100, it just adds 100. It can't grow exponentially. It's impossible. Hence, we don't include it in time complexity of integers. We just say radix sort works in linear time. Any questions? What sorting do we use? Bucket sort. Got a direct question asking what sorting would you use to sort? So answer is bucket sort, which we have already learned just before. We solved the exact problem, right? Just move a couple of slides. The first couple of slides only we solved this problem. So the problem was this, or let me make it more general, this. So if there are 0, 1, and 2 in the array, how do you sort it? Order of n. If there are 0 to k minus 1, how do you solve it? This, and then we figured out that we can solve it in order of n. So basically, you are dealing with a general case of this algorithm. Like here, you will have 0, 1, 2, ... 9, and you will have an array, and you can solve it in order of n. Already discussed. That's why we did bucket sort before radix sort. And we will do one more thing. We will run this for strings just once for, let's say, 3 strings, simple. So what happens in the first step, guys? You can write the answers on the chat. First step answer. What's the first step answer? BAB, CAB, ABC. Order is BAB, CAB, ABC. No change. What's the answer of second step? Guys, what would be the answer? Just write the answer on chat. AAB. Again, I don't sort it. What's the order in the last sort? B, C, A. ABC, BAB, and CAB. And you get the sorted order. Okay, no change, same thing. You will use again the same algorithm, bucket sort here. Here, the bucket sort, what will be the problem statement for the bucket sort? You have n elements in the array, and each elements range from A to Z. From 0 to 9, we came to A to Z. Again, solvable in order of n time. Instead of 9 buckets, you have 26 buckets. Sorry, from 10 bucket, you move to 26 buckets when you deal with numbers, letters. Okay. Any questions? How it behaves when it has different length. Different length of string. Yeah, good question. So what do we do here? Let's say you had ZZ here. So we add a character called phi, and we say that this has the this is the lowest lexicographically number. Like it is even smaller than A. Okay. Sorry, this is the so we add this in the beginning, and in case of letters, so in case of numbers, we add zeros. Okay. Let me make it clear. So in case of numbers, we add 0. You may not add 0. Like if you will see the approach. So, but yeah, explaining it, we add zeros, which is the least significant number, right? And the same way, in case of strings, you won't add phi here, right? Because strings behave differently. Because ABC will be lesser than ZZ. Okay, so you won't add it in the beginning. Rather, you will add it in the end. Okay, so you will just add a phi in the end, and you will say that it is lexicographically smallest number, even smaller than A, and just sort it, and you will get it in the correct order. So you'll add it in the end and sort it, and you'll get the correct answer. In case of numbers, you don't need to do it because I'll tell you how we will implement. But yeah, to answer your question, if the size is not same, you add characters at the end of the string, and you can name it something, let's say phi or whatever, and that will be the lexicographically smallest number. In case of when you code it, ASCII number, any character ASCII number less than A, you can choose and append that after the as trailing characters and sort it. Okay, and that will give you the answer. So this would have placed it in the first position here, but then when we sort on the second, it will come in the end, and with the third character, it will still be in the end. Okay, I hope this answers your question. Cool. So when would you use radix sort? So you will use radix sort, like the time complexity says. In case of numbers, when you will use, when you know, firstly, you can only use it for integers. That's the first thing. You can't use it for decimal point integers. You'll use it only for integers, and you will use it for and you know that it takes n times d. So you can only use it for integers, not for floating point numbers, and you can always use it, right? There is no condition when you will not use it. So n times d, you will solve the problem always. And for strings, length becomes important. If there are 10 strings and each string is of size 100, then your algorithm does not look very good, because it is dominant by the size of the characters in one string, right? So just be mindful of that, that the time complexity in case of a string is n times length of the maximum string. I think for positive integers only. There are ways where you can, let's say yes, positive integers. I'll agree. Positive integers. Only positive integers you can use radix sort. Positive integers. No floating point numbers, no mixture of negative and positive numbers. You can use radix sort to solve them. So this is the what do we say? Why we can't solve all sorting in order of n? Because these are the constraints. You can only solve it for integers which are positive, right? You can only use radix sort then. Bucket sort only on bucket sort can be used even for floating point numbers if your buckets are defined. But radix sort, since it is always solves in order of n, but you can only solve for integers, and they have to be positive integers.
So
Or
they
all the numbers are negative integers, then also you can use. So yeah, what's the question?
so they need to be within the same range as well, because we use bucket sort for sorting using the radix.
No, in radix sort, you pick a digit, right? You pick a digit. So a digit range is always fixed, 0 to 9. Does that answer your question?
Thank you.
Yeah. So bucket sort and radix sort, use cases for implementation are very different. Bucket sort you will use when you know the range of each number. Radix sort you can use anywhere if the integers are positive. Remember, integer is the key point. They have to be integers. Bucket sort is a very general class of algorithm, can be used even for floating point and negative numbers. But radix sort you can only reuse for positive integers, and they always work in linear time. So that's why this algorithm is very, very important. Also, if you cover this algorithm, you solve the string sorting as well. And string sorting, there is no better algorithm than this. Hence, radix sort becomes even more important for string algorithms. Okay, so let me quickly create another Jamboard. Exhausted the pages there. Okay, so we are doing radix, and we will write what we just said so that you guys are very comfortable when to use what. So conditions when to use. Radix sort you will use when positive integers. Bucket sort you will use when range is defined. Number is defined, how many elements are there, and range is defined. So if you have these two entities, only then you will use bucket sort. And bucket sort will be more efficient if efficient, remember, not you can apply bucket sort if you have these two, it will be more efficient if there is a uniform distribution. Okay. And this you can use only on positive. Another, like why I was not focusing on positive and negative. Can you sort all negative integers also? If all integers are negative, can you still sort them using radix sort? What will be your answer? Can anybody answer this question? If all integers are negative integers, if I give you 10 negative integers, can you sort them using radix sort?
Yes.
Yes or no?
Yes.
Yes. How?
You just remove the negative
Correct.
line and sort it.
Sort it and then
Reverse it.
Reverse the order. Okay. So you also, so that's why I was not getting into, but you need to avoid mixture of positive and negative. So if there is a mixture of positive and negative, then also you can solve, but like, okay, I will not complicate it a bit. You can think yourself how you can, but there are ways you can, but remember, it has to be integer. It never works on floating point numbers. So floating point numbers is a big no. It won't work. Okay. It will only work on integers, and it should not be mixture of positive and negative numbers. So these are big no's. You can't work in on mixtures of integers on floating point numbers. If the numbers are strictly positive and strictly negative, you can use radix sort. In case of negative numbers, you negate all the numbers and then sort it using radix sort and then reverse the order. And again negate the numbers, you get the actual numbers in the actual order. And bucket sort, you know what are the constraints. Okay, so I think that's all I had in my mind. Before ending this lecture, be very careful when to not use, because we talked all about when to use, how to use. It's also very important to know when to not use. So these are the examples like I gave. 1 million numbers. If any asks you to sort 1 million numbers, please type what would you use bucket or radix sort to solve this? Would you use bucket sort to solve this? Yes or no? To sort 1 million numbers, would you use bucket sort?
No.
No. Correct answer. Anybody else who thinks we can use bucket sort to sort 1 million numbers? No. Okay. Another question, to sort 1 million integers. Would you use bucket sort now?
Yes.
Yes. How many people say yes? One. How many people say yes? Can we use bucket sort? Yes. Okay. What are the two criteria that you need to use bucket sort? Can anybody tell? What were the two criteria? You need to know how many numbers are there, and you need to know range. Do we know
Range.
the range? Do we know the
No,
range for
right?
1 million
No.
integer? So answer is no.
Oh,
Okay.
okay.
These are the errors people will do. So these algorithms are known by very few people, and who know them, they use it incorrectly. And you sound even more wrong, right? When you say that I can sort 1 million integers in order of n time, that's an incorrect statement. You can't sort them in order of n time. Using bucket sort, you can't sort them. Now, 1 million 8-bit integers. Can I sort them using bucket sort? Yes.
Yes.
These are the cases where you will sort it. Now let's come to another trivia. 1 million numbers sort using radix sort. Can we sort 1 million numbers using radix sort? Is this statement true or false?
False.
Okay. What about others? Type or speak. 1 million numbers using radix sort. Can we sort them? Yes or no? What were the criteria to use radix sort?
Either positive integers or negative integers.
Positive integers, negative integers. You can't sort when it is floating point. So which criteria is this hitting? When I say 1 million numbers, then can it have floating point numbers? Yes. Can you use radix sort? No. Clear? Any doubts? You cannot use. Depends how many digits. Okay, we covered this. Number of digits are bounded by the limitation of memory. So in 64-bit, even a 64-bit integer doesn't have more than 18 digits. Okay, so forget about that. You can't have a 1000-digit number. You can't store it. It will be a string. When we talk about numbers, we talk about, different thing. Strings are different. So radix sort can't be used to solve 1 million numbers because the numbers can have floating point, mixture of positive, negative, all the demerits can be there. General statement can't be used. 1 million integers. Can we sort them using radix sort? What's your answer now, guys? Yes, no. Can we sort 1 million integers using radix sort? Okay, I have one yes. Can we sort 1 million integers using radix sort? No or yes?
No. Because
No. Reason?
it could be combination of positive or negative, right? It
Yeah.
wasn't.
It can be a combination of positive or negative. Now, the last question, 1 million unsigned.
Yes.
Can you sort this now? I haven't specified the range, and I'm asking, can you use radix sort or not? Answer is yes, because radix sort doesn't really depend on the range, because integers are bounded by the word size of your computer, and word size of traditional computers that we are seeing today is 64-bit. 20 years from now, it may be 256-bit. Still, the numbers would be probably 60 digits. You can still use it in constant time. With respect to, if there are 1 million numbers and the solution is 1 million times 60, you still say this is linear algorithm. You ignore this. Okay, so that's all. I think we covered all the aspects. So the places where you would use bucket sort, you go from this class and you say you read bucket sort, somebody asks you when you'll use, traditional answers are 1 million 8-bit. You get my point. It can be combination 2 million 16-bit, 5 million 8-bit also, like not 1 million and 8. These are not the main thing. 1 million 8-bit integers, you can sort using individual bucket sort very easily, because the range is also very much defined. 0 to 255 in case of unsigned, minus 127 to 128 in case of signed. These are the cases where you'll use radix sort. Close your eyes and use it when you want to sort strings. There is no ifs and buts. You'll always use it. Okay. Only case you'll not use it is the number of not use, or you can think of other algorithms, because we are not covering all string algorithms. We'll not discuss about that. It is depends on n times length of the highest string. If there are 10 strings and each strings are of size 1000, then radix sort is the not correct algorithm. But in general cases, let's say 1 million strings you are sorting, each of length 100, you will use radix sort. Okay, remember, this is the constant. You don't need to remember constant, you just need to remember the time complexity, which is n times the length of the maximum string. So you'll use, for strings you'll always use, and this will be the time complexity. So you can be wise enough to know when to use and not to use. For radix sort can be used for numbers always. Only cases when they can not be used is when it is mixture of positive and negative, and if it has floating point, then as it is, it won't work. So we will not use. These are the cases when you will not use. And when you will use, if there are positive integers, you will use it. If there are negative integers, then also you will use it. So these are your takeaways. That bucket sort you will use on the problems where number and range are defined. There you'll use bucket sort. There are two types of bucket sort: range bucket and individual buckets. Range bucket sorts time complexity is n square by b plus n. Okay, and individual bucket is strictly linear, order of n. So when you create range buckets, remember b is very important. B is the number of buckets. So larger the number of buckets, the more efficient your algorithm is. Okay, and radix sort is time complexity is n times the length for string, and strictly order of n for numbers. Okay, so that's all for today. That's all I had. I have the codes for these algorithms, both radix sort and bucket sort. Maybe we can share it to you via some GitHub link. You can go through the codes. It follows the pattern which I have used in today's lectures. Runnable Java code, and I'll be happy to share it with you guys if you want to use them, or you can just find it anywhere else. It's filled all over the internet. I will share this through a GitHub link probably, and I'll leave that to the organizers how they want to communicate. For all other purposes, like where will you get the recording, how can you join the course, contact the person who invited you or shared you the link. I am an instructor. I think Aditya can take over now, like I am done with my lecture. If there are any questions regarding when the next session will happen and where you will find the code, like Aditya can answer those questions. You should have his contact, and he is also here right now. So that's all from my side. Aditya, if you have anything to say, I can hand it over to you, else like I'll end the session. Okay, I guess, let's see. We'll be sharing after the session. So Aditya will share the recording after the session. Yeah, Aditya, go on.
Yeah, so thanks for joining, and then we'll be sharing you the recordings and the associated code, maybe in the mail. So you might be getting mails from us. So we will be sharing you all the details through the mail. Thanks a lot. Thanks for joining.